Find the x coordinate of the maximum point. Easy. So we are given a cubic function with a positive coefficient of x cubed, so we know the shape will be a positive cubic. So just looking at that, we are looking for the x value of this maximum point. Awesome. Again, looking at the sketch, what defines a turning point is that it has a gradient equal to 0. Right, so the gradient at a turning point is equal to 0. So we are looking for the gradient function, right, in order to then find the x values of the turning point. So finding the gradient function, dy by dx, we take the derivative of each polynomial term. So 3 multiplies by 2 to give 6. We then subtract 1 from the power. So the derivative of 2x cubed is 6x squared. The derivative of minus 42x squared, we take the 2, multiply it out the front to give minus 84, and we subtract 1 from the power, leaving us with the power of 1, which we don't need to write. The derivative of 240x is plus 240, right, because it's x to the power of 1, multiply it up the front, we get 240, subtract 1 from 1 gives 0, x to the power of 0 is 1. And finally, the derivative of a constant is 0, because it has no gradient, or its gradient rather is 0. Great, so we found the gradient function. And we know that gradient of turning points are 0. In other words, dy by dx equals 0. So we can substitute in 0 into our gradient function for the gradient. And we get this quadratic equation. Now when we solve for x, that x value will correspond to the x values of, in this case, both turning points, because it's a cubic, so we expect 2 turning points. And then we need to determine which one is the maximum point. Alright, so solving this quadratic equation, a few ways you could go about it. I'll show you the easy way, because why not? Menu on our calculator, equa, for equation solver, we are solving a polynomial, f2. Oh, it is degree 2, because it is a quadratic. And in for a, b, and c, we put the coefficients. So a is 6, execute, b is minus 84, and c is positive 240. We then hit F1 to solve, and we get x equals 10 or x equals 4. Now, that might seem like cheating. This is a calculus paper, so we don't actually need to demonstrate every single algebraic step. However, let's do it the algebra way, because we're here to learn. So that was just showing you how to do it on your calculator if you're in a pinch. Otherwise, we could factorize. So I see a common factor of 6 in each term. So I divide everything by 6 to simplify it. 84 divided by 6 is 14. 240 divided by 6 is 40. Alright, so we've simplified the problem. I'm now factorizing two numbers that multiply to positive 40 and add to negative 14. What's that? Negative 10 and negative 4. Well, we should know, we just solved it before. Right, so they multiply to give negative 40, they add to give negative 14. And then solving this, either x minus 10 equals 0, which means x equals 10, or x minus 4 equals 0, which means x equals positive 4. So again, that is solving it algebraically. However, you can solve it using your calculator. All right, again, what do those points mean? Well, they are the x values of the turning points. The x values of the turning points. So let's actually just give us some room here. Sorry, algebra. Sorry, not sorry. So we have our x values. Now, which one is the maximum? Which one is the minimum? Well, looking at our sketch, we know that for a positive cubic, max comes before minimum. So therefore, max is at x equals 4. Right? Because we know what a cubic looks like, the maximum comes first. In other words, it has the smaller or the lower x value of 4. So that's one way of justifying it. However, while we're here to learn, so let's look at another couple ways we can also justify it. The y value of the maximum is greater than the y value of the minimum. So, if we find the y values, we can then compare them. So option 2, so at x equals 4, substituting it into our function, y equals 2 times 4 cubed minus 42 times 4 squared plus 240 times 4 plus 8. And when you evaluate that, you'll get some number. I can't be bothered, right? And at x equals 10, you will do the exact same thing. Substitute in 10 in for x. And you'll get a different number. And you will find that this number for x equals 4 is greater than at x equals 10. Therefore, the maximum is at x equals 4 because its y value is greater. Right, so that's another way you could justify it. And just for completeness, I'll show you one more way. So if you look at the maximum point, what's the gradient of the maximum? Right, it has a gradient of 0. Just to the left of it, it has a positive gradient, and just to the right, it has a negative gradient. So x1 we know is 4, so we could pick, let's say, 3.5 and then 4.5. So just to the left and just to the right, we find the gradient using our gradient function. And if it's positive just to the left and negative just to the right, then it must be a maximum point. Right, so I won't do all the working for you. You can do it yourself. So the derivative at x equals 3.5 is something. The derivative at x equals 4.5 is something else. And we would expect at 3.5 it will be positive, and just to the right it would be negative. Therefore, maximum at x equals 4. And I chose 3.5 and 4.5 just arbitrarily, as long as your point just to the right is less than, in this case, less than 10. Right, so I could have chosen 3 and 5. It would have been a bit easier to calculate perhaps, but I mean, use your calculator anyway to make sure you're correct. So those are 3 different ways you could justify why it's a maximum. You only need to show one of them. So just to recap, the question asks us to find the maximum point of a curve of a cubic. We first sketched it to acknowledge there's a maximum and a minimum. We know that the gradient of a turning point is 0, So we found the gradient function and we set it equal to 0. So in doing that, we're showing you we can differentiate and start to use that information, so that is achieved. Going on from there, we solved for x using our calculator or by factorizing, and then we had to justify which x value was the maximum using any of these three options. Right, and the option I didn't show you is called the second derivative test, so you can have a look at that online as well. See ya.